Unit 1A, Lesson 6. This lesson will align with 4.3 and 4.4 in your textbook. There's two standards we're going to discuss in this lesson. The first one, use the definition of congruence in terms of rigid motions to show that two triangles are congruent if and only if corresponding pairs of sides and corresponding pairs of angles are congruent. The second standard, explain how the criteria for triangle congruence, angle, side, side, and side, follow from the definition of congruence in terms of rigid motions. First thing we need to do is discuss what side, side angle side, and angle side angle are referring to. We'll start with the side congruence postulate. What this postulate says is if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. If two triangles are congruent, that implies that all three corresponding sides are congruent and all three corresponding angles are congruent. So there's 6 total parts that are going to be congruent. So if we focus on these two triangles down below, we have triangle ABC and triangle XWY. What these lines mean, we have a single dash here and a single dash here. That single dash tells us that these two sides are congruent. The double dash and the double dash, that implies that XY and AC are congruent. Same thing with the 3 dashes. That implies BC and WY are congruent. So we have these 3 statements that we know are true. Side AB is congruent to side XW. Side AC is congruent to side XY. Side BC is congruent to side WY. So we've shown from the picture that all 3 sides are congruent. That implies that triangle ABC is congruent to triangle XWY. That's what that statement in the middle here means. We have an equal sign with a tilde above it. This implies or means congruent. So if those two triangles are congruent, all 3 side lengths are congruent, corresponding side lengths, and all 3 corresponding angles are congruent. Now we're going to discuss the side angle side congruence postulate. If two sides in the included angle of one triangle are congruent to two sides in the included angle of a second triangle, then the two triangles are congruent. Again, we have triangle ABC and triangle DEF. The information we know from the picture is that AB is congruent to DE, that first statement over here. We also know that BC is going to be congruent to EF. And we have angle B is congruent to angle E. What it means by included angle, we have these 2 side lengths. The included angle is the angle that's formed between those 2 sides. So this vertex where these 2 sides meet, that is the included angle. Now according to this postulate, if we have 2 pairs of congruent side, we have AB is congruent to DE and BC is congruent to EF, and the included angle, angle B, is congruent to angle E. Since we have those 3 parts, according to this postulate, we can determine that triangle ABC is congruent to triangle DEF. Since these 2 triangles are congruent, we know all 6 parts are congruent. The 3 corresponding side lengths and the 3 corresponding angles. The third congruence postulate in this lesson is the angle side angle congruence postulate. This says if 2 angles in the included side of one triangle are congruent to 2 angles in the included side of a second triangle, then the 2 triangles are congruent. So we have triangle ABC, triangle YWX. We know from the picture that angle A and angle Y are congruent. We know angle C and angle X are congruent. And side AC and side YX are congruent to each other. According to this postulate, if we have those 3 pieces of information, then we can determine that these 2 triangles are congruent. Triangle YXW is congruent to triangle ACB. Now, one thing we can discuss here when naming this statement down below, showing this congruent statement, it doesn't really matter in the first one which vertex we start with to name that triangle. I could have named this triangle WXY. and said that it's congruent to triangle. Now this part matters. Each of these vertices in the first triangle, when we name the second triangle, we have to make sure the corresponding vertices line up. So if I started with vertex W, the corresponding vertex in the other triangle is B. So I need to make sure I name letter B first. X corresponds to C, so I need to make sure I name C second, and then finally A. So it doesn't matter how we name these triangles as long as corresponding vertices align with each other. To end this lesson, we're going to discuss those two standards we had at the beginning of the lesson. The first one, use the definition of congruence in terms of rigid motions to show that two triangles are congruent if and only if corresponding pairs of sides and corresponding pairs of angles are congruent. So we've been discussing this whole lesson. We know that if two triangles are congruent, all three pairs of corresponding angles are congruent and all three pairs of corresponding side lengths are congruent. We'll think back to when we were discussing rigid motions. If we have a rigid motion, that preserves side lengths, those distances, as well as angles. So we can perform a translation, a rotation, and a reflection, and those shapes are not going to change size. They're still going to be congruent because we're not changing the angles or the side lengths. So if I start with triangle 1, and then I perform a translation and slide it over to get triangle 2, and then I reflect triangle 2 across this line to get triangle 3. Well, I know because I performed two rigid motions, a translation is a rigid motion, a reflection is a rigid motion. I know that by this theorem, by the definition of congruence, that triangle 1 and triangle 3 are going to be congruent. Because rigid motions do not change the size, angles are preserved, side lengths are preserved. Also, we know that, say I tell you these two pentagons are congruent, the first one and the second one. I know that if they're congruent, I can perform a series of rigid motions to get the first pentagon to lie on top of the second one. Doesn't matter if it's a translation, rotation, reflection, depends on the problem we're given, but I can perform either one rigid motion or a series of them to get those to lie on top of each other. In this case, all we would have to do is perform a translation to slide that first pentagon onto the second. Okay, so relating the congruence in terms of rigid motions to the congruence of two triangles, all three corresponding angles are congruent, all three corresponding side lengths must be congruent. The second standard from this lesson is going to be very similar. Explain how the criteria for triangle congruence, angle, side, side, and side, side, follow from the definition of congruence in terms of rigid motions. Suppose we have the following triangles. We have triangle ABC, then we have triangle A prime, B prime, and C prime. We're provided with three pieces of information. We know angle A is congruent to angle A prime, side AB is congruent to side A prime, B prime, and side AC is congruent to side A prime, C prime. What the standard is saying is that if we have these three pieces of information, we have side, angle, side, we know these triangles must be congruent. Also, if we perform a series of rigid motions, we know rigid motions don't change the size of the triangle or the shape at all. So if we perform rigid motions, these two triangles are going to be congruent. So I'm going to take my pre-image, which is triangle ABC. If I rotate that counterclockwise and then perform a translation, okay, I perform two transformations. A rotation, we know that's a rigid motion, it doesn't change the size. Then I perform the translation, that's a rigid motion, it doesn't change the size. So if I perform any series, I know these two shapes, these two triangles are going to be congruent, and they are. They lie on top of each other. So angle, side, and side, side. Those congruence theorems create congruent shapes, congruent triangles, as well as any series of rigid motions is going to create two congruent triangles.